In this question, we have a particle moving in a straight line, and we're given the velocity of the particle between 0 and 10 seconds, and this is split into two different functions. Now, part A requires us to find out the maximum speed of the particle. So what we're going to do is we're going to have a look at each section separately and decide which one will be the maximum speed. Now remember that speed is different to velocity. So speed is the magnitude of velocity. So that means that negative 16 meters per second as a velocity is actually a speed of 16 meters per second. So let's start with the first section. Now this is a nice linear section. We've got v equals 2t. So that means that the maximum speed is going to be at the end of the section when t is equal to 4. So let's have a look. When t is equal to 4, we have v is equal to 2t, which is equal to 2 times 4. So that has a maximum speed of 8 meters per second. The second section is a negative quadratic. So for this, the maximum speed could potentially be at the maximum point. So to find this maximum point, I'm actually going to differentiate. So I'm going to find dv by dt, which in this case is going to be minus 2t minus 5. And because I know maximum points happen when the differential is equal to 0, I'm going to set this equal to 0 and solve this equation. So rearranging this is going to give me t is equal to 5. Now if I substitute this back into the equation, so 9 minus 5 minus 5, this gives me a maximum speed of 9 meters per second. Now, because this is a negative quadratic, we've got this sort of shape like this, and we've just found the maximum point. But potentially, we could have a negative velocity at the end here that actually has a bigger magnitude than 9 meters per second. So we're going to have a look right at the end when t is equal to 10 and see what our velocity is at this point. So when t is equal to 10, I have 9 minus 10 minus 5 squared, which actually gives me negative 16 meters per second, and that's our velocity. But remember that speed is the magnitude of velocity. So actually our maximum speed would be 16 meters per second when t is equal to 10. In part B, we are asked to work out the distance that the particle moves between 0 and 10. Now, remember that distance is different to displacement. So displacement tells us how far away a particle is at a particular point. But at that point, it could have travelled any number of distance. So we need to actually look at these sections separately to work out the actual distance travelled. Now, I'm going to start by just drawing a quick sketch of what's going on to help us decide how to tackle this problem. So in the first 4 seconds, we've got a nice linear 2t, and this is up until our 4 seconds. We've then got this negative quadratic, which loops round and comes down. And we know that the maximum point is at 5. We'd already worked that out. It goes all the way down to negative 16 on the velocity, and that happens at 10 seconds. The only thing we don't have is where it crosses the axes here, and that's really nice and easy for us to work out because that's happening when the velocity is equal to 0. So I'm just going to start by finding that point on my intersection by letting v equal to 0. And if I rearrange this, I'm going to get that t is equal to 2 or t is equal to 8. Now, having a look at our graph, t is equal to 2 doesn't make sense in the context of what we've got because this function is only valid between 4 and 10 seconds. So it must be t is equal to 8. Now, to calculate the distance travelled, we're going to find the area under the graph. You can see where I've highlighted, we've got 3 distinct areas. We've got between 0 and 4 seconds, we've got between 4 and 8 seconds, and we've got between 8 and 10 seconds. Now, the first section is the expression v equals 2t. And we know that to find the area below a graph, we integrate the function between those limits. So I need to integrate 2t between 4 and 0. And when I integrate 2t, I'm going to get t squared between 4 and 0. And if I substitute those limits in, I'm going to get 16. Next, I'm going to integrate my 9 minus t minus 5 squared between 4 and 8. And this gives us 26.6 recurring. Next, I'm going to integrate the same function between 8 and 10. This gives me negative 14.6 recurring. For my final answer, I'm going to add the magnitude of these values.